All right, hello everyone. Thanks for coming. Appreciate it. My name is Don Gillett. I'm a principal architect at Microsoft. And today I'm going to be talking to you about developing mesh applications. So about 6 months ago, we had released some of our first experiences related to the mesh back at Mix '08 timeframe. And what that was centered around was mostly the user experience pieces for live folders. So there were some other features in there like desktop sharing, and those went over very well. But kind of the focus that was an end user piece for synchronizing folders. So today we're starting to release the next stages of the mesh. We're releasing to all of you the ability to start writing your own applications for the mesh. And so if you go to azure.com, you'll be able to go ahead and sign up for tickets to get onto the CTP for that. So what I'm going to do is walk you through some of my experiences I had working with the mesh. So about 3 months ago, I was able to start working with the APIs and the live framework that we're releasing to you today, and got a taste of writing mesh apps. Was able to give some feedback back to the core team, and kind of pave the way on that. So we'll kind of go through my perspective on that. So a little bit of a map to kind of tell you where we're talking about in the grand scheme of things here and what you're learning about this week. The mesh is part of live services. So if we had to put our pin on the roadmap, here's where we are. And mesh data services is a portion of that. So there's Windows Live ID, there's many different components of that, but I'm going to drill in mostly to the mesh parts of that with this talk. And if I had to give sorry, my slides are, there we go. If I had to give the one minute talk about what I'm excited about the mesh and what new scenarios enables for me, it'd be this picture here. Users want to get access to their data at any time, at any place, on a multitude of different devices. So whether it's accessing it from a web page at a kiosk, whether it's on a laptop that I'd have to disconnect and go on an airplane and still get work done, or on a mobile device. And so that's the key scenario that when I was thinking about what application do I want to build, that's the scenarios I went after. So we all sat down and brainstormed a little bit about what the first things we want to do, and there's tons of ideas that came across. And one of the first things we wanted to do was go after some simple scenarios that we haven't been able to meet real well with the tools we have today. So I'm sure all of you have been working on your computer at work and had one last little bit of detail you need to leave for yourself, so you send yourself an email message. And that's to get that little bit of information from your home PC or for your work PC back to home, for example. And what I equivalent that is taking scraps of paper that are on your desk and throwing them in your filing cabinet in something that's supposed to be real organized. So we're going to see if we can build a little bit better tool for that. The other thing, key scenarios are things like that we just don't have real great tools for today, like shopping lists or a weekend to-do list, things that write on little scraps of paper. So the other analogy that we like to use is it's my digital junk drawer. Things that don't have a place yet, I can put them in here. I can share those with a family member or a friend, and have those roam around with me. So I'm going to drill into a demo of Jot. So this is the application we've been doing. I'm going to back up 1 second here. So we actually delivered 2 applications with this in 2 different form factors. When you write mesh applications, there's many ways you can go about writing apps. You can write a web page that talks to the mesh. You can write a rich desktop app that talks to the mesh. I've done 2 different flavors of our application here. I've done a desktop app, and I've done a mesh application, which is a Silverlight app that I can embed in the mesh desktop. And so I'll show that to you today. If you're not dealing with Silverlight, there's still many ways to talk to the mesh. You can write DHTML apps if you're doing an embeddable mesh application. JavaScript, there's lots of great libraries. I happen to be a .NET developer, and so that's what I'm going to focus on today, but you'll learn some tidbits of information that will apply to all those different scenarios, whatever tools you pick to program against the mesh. So let's switch over to the demo box here. So here's mesh. Here's Jot. This is our desktop app. It's a very simple app. I've got a bunch of lists I can pull up and flip through my different lists that I have here. So for example, here's an expense list. I've started keeping track of some of the different expenses I have, and I could have this on my mobile phone, I could have this on my laptop, I can have this at a kiosk access. So it's anywhere access to a real informal list, something I just threw together. Might have a shopping list, and I may share this with my wife, for example. And if I'm at work and I realize, oh, you know, we ran out of toilet paper, I can add that to the list real quick. If I wanted to go in and flag that as, hey, that's actually pretty important, I can go do that. And when she's there shopping with her mobile phone, then she'd get that synchronized to her. She'd see, oh, there it is, great. I don't have to wait till I get home to add it to the list. So that's the scenario. That's the power of mesh, is getting that data replicated and getting it to all your different devices. So we talked about different ways of accessing the same set of data. So now I'm going to switch gears a little bit here. And I'm going to go to the live desktop. I'm going to show you what this is in a mesh application. So if any of you have been on the mesh CTP or the technical preview of that, you will have seen this live desktop before. This is a web page that I can view at a kiosk or at another PC, wherever I'm at. And I have two live folders here. So the live folders are where I can do all the sharing of my files. I can map a drive or a folder to one of those live folders, have it replicate up, and then that data roams with me wherever I want to go. I can access it from the web. So now we're introducing mesh applications. So here are a bunch of different checklists I have, and I'll go over my checklist sample later on. And I've got my expense, my shopping list, my web favorites, my weekend projects. These are all the lists that you saw over here in my rich desktop app. I'm just viewing it from another app. So let's go look at the mesh application here. I can go say, go ahead and synchronize here from the other side. So this app is written in Silverlight. This could have been written in DHTML if I need to have some more reach. If I wanted to have a little bit richer experience, or I wanted to have a platform that I'm used to developing in .NET, I can go and embrace Silverlight. And with Silverlight getting more and more reach, this is a much more viable option here. So I can go add an item on this side. So let's say I needed ketchup. Add that to the list. It's the same list on the other side. The lists that I have on this are very simple schema, different properties that I can add. I can come in and add different custom properties, so some real lightweight list creation. Now, let's go back to the rich app. So if I've got the ability to do Silverlight app, I've got the ability to do the rich desktop app, what are some of the reasons what I would want to do these different platforms? Well, one of them is if I'm going to do some rich integration with desktop scenarios, then I'm going to want to do a full Win32 app. I'm going to want to have that ability to reach into all the great features that Windows has. So let me jump over here and show you some integration that we did with IE. We've added a add to Jot favorites here. So if I find some article where the jobs are, and I want to share this with somebody, I can just say add to Jot favorites, come up and add a favorites here. Now, why is this so much more powerful than just favorites? Well, one, I'm sharing it. I can share it out to other people. And two, I can annotate this with a bunch of notes. You know, check out line 2. Save that. That's going to go into my web favorites folder. And there's that note. So now I have a set of searchable favorites that I can share out with people. And I'm fairly new to WPF and Silverlight. I've been doing that for several months now. There's a ton of great blogs on these different features. And this is where this was kind of an aha for me, that I would have this huge, massive list of favorites, and I couldn't search on my own annotations. So this allows me to annotate those for myself, be able to search those, share those with team members that I might be working on. OK, so let's move on to the next step here. I'll go over some of the key takeaways of what I found out in my experiences with developing this. So first of all, the Live framework, which is the set of libraries that lets me talk to the mesh, it's just another great component for .NET developers. So you've all added in new libraries before. You add an assembly to your app, and you can just start coding with it as everything else. So there's a great set of tools, and I'll show some examples of how to get started using those libraries. Second thing is that synchronized data is the heart of mesh, and it's very easy to utilize. So I'm going to show you 3 different sets of objects that allow me to get to all the data in my mesh and to enumerate through them. Mesh applications work great with Silverlight. And when you start writing an app like this, there's kind of 2 things that you key on a lot of times. And that's one, how am I going to store my data? That's one decision you have to make. Am I going to do a database or flat file storage? So what's my strategy for doing that? And the second is, how am I going to show this? So Silverlight's a great pairing with this technology. It leverages a lot of the WPF learning that we've been all doing. So I'm very excited about having this pair. It's a very great environment for rapid development. One of the things I learned was that if you are careful enough, you can actually share a ton of code between these Silverlight and WPF versions. So about 90% of the code that I've written on this app just cross-compiles. And so I'll show some tips on how to do that. And it's just even getting better and better. Today at the keynote, you probably would have seen some of the control pack for Silverlight that was announced. And that's one area that, for example, my app was different as I had to use a different grid in the 2. Now I can consolidate that code, and I'll have most of the code running for both those platforms. So it's a very good story on that. And the best part is what I didn't have to do at all. So there's just a ton here that allows me to get an application where I'm sharing off the ground without having to tackle those on my own. So inviting, authentication, user management. So these are things that you'll see as we do our step through of code that I just pick up those for free, and then I can take advantage of those as I want to make my application richer and richer. So there's actually quite a bit of work that would have been involved in getting that sharing scenario up and going. So getting started with the mesh. So let's start diving into a little bit of code here. Very easy to do. We add a using here at the top, Microsoft LiveEffects.client. I have 4 objects here. I have this mesh object. I'm going to hide the details a little bit of how to make that connection right now. Then I've got mesh objects. These are my containers. And so I'm looping through each one of those. Within a mesh object, there's a data feed. So I can loop through those, and then data entries within those. So this is kind of the canonical sample of how to get at data in the mesh. And we'll go into the details of each one of these. So storing data in the mesh. So I mentioned these mesh objects, data feeds, and data entries and enclosures are the 4th element that are going to make up our mesh hierarchy. So mesh objects are our top-level container. So when we develop an app, we need to decide what are we going to model our data? What containers are we going to put this in? You'd have the same on the desktop. What am I going to have be a file? What am I going to have be a database table or an entry in it? So when you look at a mesh object, that's the unit you want to share. If I want to share a unit with somebody, that's a good top-level container to think about. Live folders models a mesh object as a folder. Subfolders underneath it are not mesh objects because you can't share subfolders independently. Jot, each list I had as a mesh object. If I wanted to start to share this list and then I want to share it with somebody, I want that as a shareable unit. Mesh objects can contain one or more data feeds. So data feeds represent the collection of items that you want to have in your mesh object. So in my case, for Jot, I had each item in the list, each list only had one data feed. So I didn't need to have multiple data feeds. Now, when would you do multiple data feeds? You do multiple data feeds when you want to do big chunks of operations against it. Like if I want to delete a whole set of a subfolder, or if I wanted to delete a whole subset of a list, then I might think modeling that as a separate data feed within my data object. So data feeds, you can look at them as if they were RSS feeds or syndication feeds. So data entries are the chunks of data that are inline in those feeds. And so that's the smallest unit of storage that I would want to merge. You want to model your app so that the things that you're going to merge are going to be isolated as a data entry. And so that way you don't have to pick apart the piece. They can just mesh together naturally, and I don't have to do conflict resolution. So avoiding conflict resolution is kind of the job of what we want to do when we pick of how we want to put our data in here. So, and then what happens when your data gets really big and I don't want to put it in line with my feed? That's when we have enclosures, and enclosures can be large streams of data, and they're referenced off of data entries that I can enumerate through. So we're not doing this in JOT today, but eventually once those notes fields get really big, I'll want to overflow into enclosure. I won't want to put that in line. And here's the model of that. So from mesh, I can get to mesh objects, to data entries, and then down to the media resources of the enclosures. Okay, so let's, I'm going to set up a walkthrough of some code here, and there's some background that I want to set up here. So one of the things we're going to do is we're going to evolve some code from step 0, which is where I could have a traditional app that serializes something out to a file. The next step is I want to start reading that data rather than from a file, but reading it from data entries. So I can start reading it from chunks. And then my final evolution of this app is going to be to using feed sync. And so this is the first time I've introduced the term feed sync. And let me just say a few things about it. So feed sync is kind of the underlying mechanism of how the mesh synchronizes data. You can think of it as the feed of your data with some extra entities on it. So when I have a data entry, there's some extra things I need to do in order to deal with synchronization. Synchronization is actually a very, very hard problem. Things like when I delete an item, I need to have a tombstone for that item. If you've loaded a list and I've loaded a list and I go delete an object, you need to know about it so that you can pull it from your list. Otherwise, you might think that's a new object that you put in there. So when you start dealing with synchronization, it actually starts getting to be a much quicker, a much harder problem than just loading from these chunk streams. So let me say a little bit about Silverlight and WPF data binding. So if there's one tip I could give in starting down the .NET route, if you're doing the first time with a mesh app, it's to go ahead and embrace kind of the data binding. It's a great facility. It makes, when you deal with asynchronous programming and asynchronous data access, it's all that much more important to have these mechanisms set up in your application so that when you change data, notifications come up to your UI and your UI can react to it. All too often, when, earlier beginning developers will start doing things like delete something and then delete it from the list. Well, if you just deleted the item and then had the notification trickle up, that'd be a lot easier. And when you're doing changes that synchronize from the web, it's all that much more important. So there's a couple things. I notify collection change. I property notify. There's an observable collection. All these are in Silverlight and WPF. And there's some great articles on how to use those. One gotcha about notifications is when you do notifications into WPF or Silverlight, those notifications need to happen on the UI thread. If not, then you get these errors that happen where the UI is protecting it to have calls that just come on that UI thread. So there's a couple ways to deal with this. One is that the mesh libraries themselves will marshal the calls back to the UI thread when they come back off asynchronous operations and give you notifications on those threads. So that's one thing that helps. But if you're doing any breakout on your own, there's a couple of articles about how to do that marshaling yourself. And it's pretty easy. Here's a search on some articles that I had come up with on dealing with this topic. So you can grab the slide afterwards and look for those. So some great articles on that. I mentioned data changing from outside sources. So the network changing the data and having that trickle up. I'm going to walk through an application called Checklist. It's a stripped down version of JOT. When you start trying to write applications for real, they get too heavy to try to show as a demo. So this is a stripped down version of that. It just covers some of the basics of it. So we're going to have a checklist. And it's going to be a list of checklist items. And in that, I'm going to have, is it checked? And what's the title? And that we're going to keep it that simple and possibly who checked it. So normally, when I have a property on an object like a checklist item, you would have some accessors, get checked, set checked, and a private member variable. Well, what I'm going to do is store all that on another object, which is a private data structure to this. And what that's going to allow me to do is handle some of these notifications. So this will become really obvious as we get into the code why I'm doing this, and it's a pretty good pattern for doing these. If I start doing data binding, against these items, and I have a change of my data. So the data's changed from some outside. I can go replace that inner item of data that actually contains the blocks of data, and my overall wrapper doesn't get removed from my list. This makes my data binding much more stable. So if I've got something in a list and I change that item, I don't really want to have it delete and come back. That changes selection when it may not be something that needs to change. So one tip to take away on dealing with some of these asynchronous data access. So let's walk through some of the code on this. So here's our starting point. It's not. I'll try to find a way to make this available and get back to you on that. Maybe at the end, if you're interested in getting this, I'll see how we can get that to you. So checklist item data. This is this chunk of data that I said we wanted to pull out separately from our item. There's another reason why we're going to pull this out, which is for serialization. I can serialize this whole thing into a data entry now. So if you'll see that we have data contract and data member. These are attributes I put on this object, and it makes it so this is serializable. That's all I have to do to make it serializable. This is a construct that's also used in WCF, and it basically is predecessor to some of the older serialization. Let's go into checklist item. So checklist item, remember I talked about this I notify property change. It's an interface that tells things when things change. I'll show you the implementation of that down below. I've got a back pointer back to my checklist. Got the item data I'm holding. Here you'll see my properties. Normally you'd see like an is checked that would just go to this dot is checked, but this is going to that chunk of data that I mentioned. I have one method to update the item, and I just take whether or not you've checked it or not, and and who it's been checked by. And as I change those, I fire these property changed events, and so those will make my UI bindings update. And then I call back to the list saying the item's changed, and and the list is going to handle saving that away. We'll cover that in a second. And here is my iProperty notified changed, and that's pretty much it. So let's go to the checklist now. The checklist has an observable collection. That's what allows our list to have the binding and the change notifications. A couple of methods for creating and deleting these items. Now, this first step is not mesh. I'm going to have a load and a save. That what I'm going to do is I'm going to load these from a file. And since I'm running this in Silverlight, there's something called an isolated storage that allows you to get at a part of the file system even though you're running in the context of a browser. So it's some way that you can save some data. So I've just used this as a nice, cheap, easy way in this demo to load up this code. So let's go ahead and run this. I've got, I didn't show you my Silverlight page, but I'll go back and touch on that. And so here's a couple items I had on here. I can add another item. I can check that. I'm going to hit F5 and reload it. And you see that the same items came back. So that's our base. So that's what we're going to start with. Now I said I'd show you the Silverlight markup for this, and here that is. Pretty simple page, and here's where my data binding comes in. I'm binding my list to my items property, and the checkbox and text box I'm binding to my is checked and my text property on my checklist item. Okay, so let's meshify this. That's what we're here to learn how to do, so let's do those next steps. So this next sample has our first step of going to data entries. Okay, so this hasn't changed. Nothing new here. Checklist item. We now store our data entry. This is the piece of the mesh that we'll get back when we do a load. I'm going to jump to that right now. So in our checklist, I'm going to store a data feed. Data feed was the thing inside the mesh object that gives me my collection of items I can load off of. And let's hop down to the load. So the load where we were doing a serialize, all I'm doing now is I'm getting at my mesh object, which is wrapped up in this mesh application service. I'm going to go look for a data feed. So I'm saying mesh app.datafeeds.entries, first or default. I'm just searching for one that I call checklist. So the first time I run, I'm not going to have that, so it's going to be null. So if my data feed is not null and I'm coming through and I'm loading, I'm going to go create one for the first time because I've got a blank document here. So new data feed. I'm going to put a resource type on that called checklist. I'm going to add it to my data feeds, and I'm done. That's created my data feed entry. Let's load. If I did already have an existing data feed, now I've got to load all my items off that list. So this is just a loop around the data entries. So for each data entry and entries, I'm creating a new checklist item and passing in the data entry. So let's hop into that code. This is where our serialization of each one of our items happens. So remember this data entry, this thing that we put all of our tags on it that had the serialization attributes for the data contract? Very easy to get that out of the mesh. All I do is say this.item and assign that to dataentry.resource.getUserData. So when I have my data entries, these are the smallest chunks of data that I want to put into the mesh, I can just deserialize a structure that I've defined that is marked up appropriately. Saving to mesh, very, very similar construct as I do as I'm loading off of saving to a data feed. I'm going to, if I don't have a data entry on this item yet, it's a new item. I'm going to do a new data entry. I'm going to set user data on that and then add it to my data entries, and that would do my saving. And if I'm doing an existing item, I don't have to new it up. I've already got it, set user data. Okay, so you see how it's very easy now to load a set of data. Oh, I just closed my project. So let's go on to the final step of this, which is to use sync entries. If I load from a set of data entries, and I've got that set of data entries in memory, how do I learn if there's changes externally from the network? So I mentioned feed sync and sync entries. We're going to start taking advantage of that. So the code actually doesn't change a whole lot. Let's go into the checklist item. The big difference here is that when I load, rather than loading, this line used to say data feed.data entries. We're going to go out to sync entries now. Sync entries are another collection. It's basically the same set of the data, but it includes additional information. In the load case, where's my load? In my load case, as I'm loading off of the sync entries, I now have to check whether or not this data entry is something that's been deleted. Okay? So why is it important to know if I've got something deleted? If I've got something in memory I've loaded, I need to get a sync entry that says somebody deleted it. This is a tombstone. So when I'm loading the first time, I can skip that entry. So in here, if it's been deleted, I'm going to skip it. If not, I'm going to do the same code I used to do. I'm going to initialize my object, pass it the data entry. It's going to load off that object. Now, in the case of a synchronize, at some point during the running of the app, I might decide it's time to go check for changes. So if I call a synchronize on this, then what's going to happen, let me see, sorry about this. If I call synchronize, what I'm going to do is call onto the data feed the sync entries and call synchronize. Now what's this doing? As I make changes to data entries, they're getting buffered up locally. What this allows me to do is it allows me to send all my changes up at once and then get back any changes that the server has detected. So if I say synchronize, I'm sending up my changes, I'm coming back with other changes, and I need to loop through those changes. And there are 4 cases I need to worry about in that. So one of them is as I find, this is a new function I've added, which is to find an item. When you have sync entries, you get a unique ID for that item. And so I have to be able to find the item in my list, and I need to see If I didn't have it, in that case, there are some times I need to deal with it. So if the item has been deleted and I have the item in my list, I need to remove it from my list. Somebody outside changed it. Case 2 is I have this item in memory, and it's possibly been changed. So I got a new data entry back. So I need to hand off to the item and let it fire its logic of, hey, here's a new sync entry. What do you want to do with it? Then in the case, if it's been deleted but I don't know about it, that's just somebody who's added something and deleted it before I ever found out about it. I don't have to deal with that. And the final case is I don't have this in memory, and it exists. The server told me about it, so I need to add this to my list. Now, the great thing is, anytime I call one of these and I've got the data, these notifications set up, as I add these into these lists, my UI is just going to react. Items are just going to show up and go away. One final function I think is worth looking at here is this synchronize on the item. So this is the case where we detected that the item might have changed. So on a sync entry, there is a function called compare, and I can see if it's actually changed. Now, I can get back a compare result, and this is where I would do my conflict detection. If I have two items that have changed, I have to have an algorithm that determines what I want to do with it. And so then I might want to actually crack into the data and present some UI to the user. But in this case, I'm just going to take whatever's newest. So whichever one's newest, all I'm going to do is deserialize that chunk of data with this get user data and fire properties that all my items have changed. It's kind of a cheap way of getting through this. Okay, so let's go on and see that running now. Okay, so here's our sample 2. This one's been loaded off of the data entries directly. I can come in here and add item 4. It'll show up. I can do the check. Now, if there was an outside browser that was clicking on these or checking these off and adding new entries, I would know about changes. This was the one that was loaded off data entries, not sync entries. So this would require a reload in order to refresh that set of data. Our next example is running off of sync entries. So this one, if there were changes coming from outside, then I would get those changes and they would go pop up into there. So there was one thing that you noticed on here. So I'm going to go through a couple of tips in getting started when you start developing these. There's a couple things I had to work through on this. One of them, I think you saw that I had a dialog that popped up behind this. This app was compiled with having a window. If you do it windowless, you'll work around that, and that's something that we'll get fixed in there. So that when you do a Silverlight app, if you pick the windowless option, it'll work a little bit better on that. The second thing is the data entries are working quite well right now. The sync entries, we did have one little bit of a problem that you'll need to work around in the early CTP, and that'll be fixed with some QFE in the near future, which is that the calls out to sync entries are actually not asynchronous. So if you call async, it actually blocks and goes synchronous. We need to fix that. There's actually a pretty easy workaround for that, and you see it here in the Jot app. If you've got an app where you can add items very, very quickly, you may not want to send all of those entries all at once. You might want to, every time you type, you don't want to send up another entry. You want to batch those up. And that's where sync entries actually helps quite a bit with that. As I make a data entry and add it to the sync entries, it buffers up a list and then waits until I call synchronize to send it up, and then I get my changes back. So what I've done on this is I have a timer so that if something hasn't changed in the last 5 seconds, if somebody is rapidly adding items, then after that 5 seconds, I send it up. Still have a little bit of hiccup in the UI after that 5 seconds, but it solves the UI experience on that. So a little workaround until we get that worked out. The other thing that was kind of a real aha for this was that synchronous UI is really, really hard to design. So I don't know if you design UI and that have dealt with these synchronous issues of if I send some data up and I try to wait and have it show up in my UI, then what happens if it didn't go up? Do I delete it out of my UI? What do I do with that? So asynchronous is almost more of a designer challenge than it is a developer challenge. So dealing with sync entries in order to buffer up your local changes actually makes that problem a little easier to deal with, because if I make 5 changes and I buffer those up and I send them up and then it fails, well, I know I can just retry that buffer to send that buffer up again. And so at least it's one transaction. You just have to alert the user, hey, your data isn't saved yet, rather than the 3rd change ago and the 2nd one ago and the 6th one ago, and how do you manage those? So dealing with that as a buffer is actually quite a bit easier. Okay, so let's do some final thoughts. So a lot of things that we didn't cover. There's a lot of sessions later on today that go into some of the other aspects of live frameworks. So please go look at, if you go to the kiosk out here and look for different sessions of both mesh and live services, they'll show you about the 10 or so sessions that relate to these. But membership, authentication, these are things we didn't do, but we're just getting in this app. And there's a lot to go through on that. Cross-development. I was a big proponent of being able to do both a desktop app and a rich desktop app, and having this reach app that I could put out as a mesh application. And doing cross-development targeting these worked very, very well. One hint on this is that, as I have, so here's my jot. I have a jotlib and a jotlib-sl, and one hint on these is as you add existing items to your Silverlight projects or your WPF, you have to pick which one you want as your base. You can add as a link. When you add existing item, the default is to add it, but if you see that there's an add as link in Visual Studio, then that'll make a link to that project. So the same file can be in both projects, and you can cross-compile that. So we did that with about 90% of the code. The second is that there is, the pound defined if Silverlight. So pieces of code that can't be commented, you can comment those out, and you can actually get a pretty good cross-development story. Okay, some very, very useful tools. So one of them is the resource model browser. This comes with the live framework kit that you can download and get started with. What this does is allows you to point to your actual data on the server and view the data directly as it comes off the data. And it's great for looking through your data objects. You can see what objects are, the feeds. It's a very valuable tool for learning how the data is stored up on the mesh. Second tool is Fiddler. So I don't know if any of you use this. It's fiddlertool.com is where you can download it. And this is acts as an HTTP proxy that gets in the way, and you can see all the network traffic that flows to your web application. We use this internally a lot for, hey, what happened in this case with this bug? You can save whole traces of all the stuff that went over the wire, and zip that down and send that to a tester or a developer as a package for reproducing a bug. And here's kind of my final favorite trick with Fiddler. This saved us hours of dev time, which is when you embed an application like Silverlight that's going to talk back to a service, if you're going to run that from a dev box, you got to upload that to the server first and download it and run it. And that can be quite time-consuming if you've got some really big files or some, if you're just doing some really rapid back and forth. So if you initially upload your application, your Silverlight application, that gets embedded and it comes down, that'll get served off the same domain. But then if you run Fiddler, you can plug in this code that says, okay, if something comes down and is asking for my Silverlight app, I'm just going to replace it with whatever's locally. So the browser is completely tricked into running that as if it was served from the web in that context, but it pulls it off of some of my local files. So I can upload my app once, run it several times, and that's saved tons and tons of hours of time in going back and forth with that. So this session will be recorded, or has been recorded, and here's will be available. Please fill out some evaluations, and open it up for Q&A. Anybody? Yes?
You talked about the different sync cases, and if we're thinking about testing the sync cases, is there any way to automatically generate all of those, or is it a manual test?
Yeah, so this is actually a really good point of going back to kind of the cross-platform targeting Silverlight and .NET. One of the reasons to do a .NET version if you're doing a Silverlight one is you can run all the test tools like visual test projects So I actually go through, and that's exactly what I do with my object model, is I build a bunch of tests that will run through all the same code, but on the desktop, run through test cases in Visual Studio and populate all the data, can build those up, run it back through. So you get all that very easy to write to those APIs.
There's no license fees for any of this live framework, is there?
The live framework, well, it depends what pieces you are. So the hosting pieces of Azure hosting, it hasn't been announced the pricing for hosting. In terms of using the live framework APIs, there's not a licensing fees for the parts that point to public free services. So, for example, writing data into the mesh, users for free get a certain amount of data that they can store on the mesh. And you would be able to use those APIs to go against that quota for that user. Say it, I'm sorry? Do I have a blog? I don't have a blog. If you'll tell me some things you'd be interested in talking about, maybe I can get some of our prominent bloggers to cover them, and or maybe I'll start up one. The sample? I'll see if I can update the slides that get posted with a pointer to the sample once we can distribute that sample, so you can get these slides. I'm not sure if I can edit those. And afterwards, if you come up, I'll give you contact to make sure if those of you that really, really want that sample, come see me. And otherwise, I'll try to get the slide deck updated that gets posted. Yes? Well, I mean, so this is a data import problem. How do I import data to that? If you've got data that's already in two spots, you're missing some of the key data that Mesh stores in order to remove duplicates. And there's a great presentation later on today about feed sync in general, and you can go to that and hear some of the things about why you need a unique ID and why you need conflict data and everything. If you don't have that data, then the initial item, when you put two items in, aren't going to have that. There may be some ways you can precede it with this, hey, this is this item, this is the same item, and it would help out with those conflicts. But I would imagine before the data import, you might want to consider resolving the conflict before sticking it in the mesh. But there may be some ways that you could add an ID ahead of time and then have it help you out with that conflict. Yes. Right. So the question was, if I've got a bunch of really old changes, what's kind of the time frame of what I can sync on that? If I have really old items, do I get that whole list of changes? Feed sync in general, so separate from the libraries, feed sync in general has windows that you can ask for. So if you can ask for a window, go back this far and ask me for a window based off of some high watermark that you know you have. Any other questions? That's a good question. I don't know it. You definitely want a process of cleaning the tombstones, and that's related to yours. They might address that in the feed sync one, but I'm not sure. But you're right. There's a process at some time where you need to age out tombstones, or you've got a lot of data, especially stuff that gets created and deleted a lot. Yep. What are the upper practical limits of scale? I don't have that. I have in FeedSync in general and Live Mesh in general. We have hundreds of thousands of users putting gigabytes of data up on the server. Yeah. So we have users that have their quota of 10 gigabytes of data that they're syncing back and forth. So your enclosures, you can have several chunks of the different enclosures. Those are all file sizes. We have a lot of people have taken whole picture folders and synchronized those up. So it depends on your application how you break those down. If you just had one big 1 gigabyte file, obviously that wouldn't synchronize real well. But if you have lots of smaller files, gigabytes of data are what users have allocated to them.
Following up on the field question, how about 1,000 or 100,000 devices in the same single data?
For a given user? Yeah, I'm not too sure. I'm sorry, I don't know the answer to that. There may be a limit on the number of devices that a user has. The device ring and the set of devices that you have, whether that's like an enterprise scale of devices, the current intent is that it's the number of devices I might use as a user. I imagine you could come up with some enterprise scenarios where you have a different modeling of that. Yeah. Okay, well, I'm going to wrap up here. Feel free to come grab me on the side up here, too. If there's anything you want to talk about offline, I'd be glad to chat a little longer. Thanks.